Welcome back to your fall final review, PreCalculus, here 16 through 20. Number 16 says find the domain of this function. When we're looking for a domain, we're looking for any domain restrictors we have. The two types of domain restrictors we deal with in PreCalculus are rational functions, in which case the denominator can't be 0. So for example, this is a rational function we have here in 16. X plus 3 can't be 0, which means x can't be moving that 3 over -3. The other one that we might have would be a square root, in which what's underneath the square root sign has to be positive. That will restrict our domain as well. But this one is just x can't be -3. You can see that written as negative infinity to -3, union -3 to infinity. Or you might see it in set builder notation set of all x's such that x can't be -3 and x is an all real number. Right, number 17, it asks us to determine which of these guys are odd functions. So remember, an odd function is when you plug in a negative x, it gives you a negative y. So all the signs change. So for this one here, we think about it graphically. This is saying y is equal to 3. That's this line here. Graphically, an odd function has to be symmetrical across the origin. So if I have a point here, it means I have to have the same point over here. Do I have the same point over there on my graph? I do not. So we know this one is not an odd function. All right, x cubed plus 3 would be a cubic function shifted up 3. It would look something like that. Does that look like it's symmetric across the origin? No. If I have the regular cubic function, this guy here, that one's symmetric across the origin. And so that one, or about the origin, that one would be odd. But when we shift it up 3, this 3 piece kills the ability for it to be odd. So this one is not odd. How about negative x? That looks like a line that it splits the second and the fourth quadrant in half. Does that one look symmetric around the origin? Yes. So this point here would correspond to, say, roughly this point over here. If I've got a, say, -2, +1, let's just pretend like, well, I guess that wouldn't work for this function. -2, +2, over here I've got 2, -2. Both the signs change on it. So this guy does work. That would be the only odd function in number 17. All right, find the value of f of 3 if this is my function. So for our piecewise functions, first we have to figure out where does 3 live. Is 3 between -2 and 2, or is 3 greater than 2? It's greater than 2. So for f of 3, we're going to plug it into this piece because that's where the 3 lives in the domain. So I'm going to plug 3 in here. 3 minus 5 would be -2. All right, number 19, if f of x is x and g of x is 1 over x, find f divided by x. So f divided by g of x, that's f of x divided by g of x. So I'm going to put my x over my g of x. Since I got a fraction divided by a fraction, I'm going to multiply the first fraction by the reciprocal of the second fraction. So flipping 1 over x becomes x over 1. X times x is x squared. All right, which of the following numbers is not a potential rational root? No, this is really bad, Miss Harris. Why? What's wrong with this? Well, it's supposed to be a multiple choice question, but I didn't give you any of the options. So instead, let's come up with what are potential roots for this guy. So remember, our rational roots are going to come from the factors of the constant divided by the factors of the leading coefficient. So factors of constant, factors of 2 are 1 and 2, divided by the factors of 18. So I've got 1 times 18. Should catch up, there it goes. 2 times 9, I'm running out of room. Let's try this again. 1 and 18, we've got 2 and 9, and then 3 and 6. All right, so I got 1 divided by 1, so plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6, plus or minus 1/9, plus or minus 1/18. So that's 1 divided by each of these guys. Now 2 is going to give us a little relief because some of them will reduce down to something we already have. The first one is 2 divided by 1, that's going to be 2. 2 divided by 2, that reduces down to 1, we already have it. And then we got 2/3. Then I've got 2 divided by 6, that reduces down to 1/3, which we have. Then we got 2/9. And then 2/18 reduces down to 1/9, which we already have. All right, those are the possible rational roots. And that is it for this video. Coming up, the next video will be 21 through 25.